Okay, so I want to continue on with our rational exponents into the next part of it, and that is where we're simplifying our radicals. So I want to take a number like the square root of 8. And I know that you could use your calculator and you could tell me the decimal point for that. And sometimes that will work, but most of the time in algebra, we don't really want a decimal. We want to know the exact number that this equals. So we're going to talk about something that you probably did way back in the day in 8th grade, and that is perfect squares. All right, so let's take, I'm going to use my little paper over here. 1 times 1 is 1. What is 2 times 2? That's 4. What is 3 times 3? That is 9. 4 times 4 is 16. These are perfect squares. They're a number times itself to get it. So 5 would be 25. 6 would be 36, and keep going. 7 would be 49. 8 would be 64. 9 would be 81. 10 would be 100. 11 would be 121. And I'm just going to go to 12, which would be 144. Now, you could keep going. The more of these you know, the better off you are. So, I'm going to teach you something called the birthday cake. And I like the birthday cake method of simplifying radicals because it's so easy. You're going to use your perfect squares and your prime numbers to kind of get to the end. So, if I want to think about prime numbers are numbers, the only way to get them is 1 times itself. So, for instance, 1, how do you get to 1? 1 times 1. That's a prime number. The next prime number would be 2. The only way to get the number 2 is 1 times 2. What about 3? Yeah, 3 is a prime. What about 4? No, 4 is not, because 1 times 4 and 2 times 2. Okay, what about 5? Yeah, 5 is a prime. 6? No. 1 times 6, 2 times 3. So that's not going to be a prime number. 7, 1 times 7, 8. No, I can get 2 times 4. 9, 1 times 9, 3 times 3. 10, 1 times 10, 2 times 5. 11, yeah, 11 would be a prime. So these right here are going to be the prime numbers that I'm going to use. Every now and then they'll be bigger than 11, but for the most part, almost every time, I'm going to use these numbers right here. So what I want to do, using my prime numbers, I want to try and see what I can get 8 down to. So here's what I'm going to do. I'm going to put 8 down here, and I'm going to draw a little, kind of like a half cake around it. Which number goes into it? And you don't really want to use 1. Does 2 go into 8? Yeah. So we're going to come out here, we're going to put 2. 2 goes into 8 4 times. Put another layer on your birthday cake. Divide by 2 again. 2 goes into 4 2 times. Another layer on your birthday cake. Divide by 2 again. 2 goes into 2 1 time. Every birthday cake needs a candle on the top. Do I have a candle? Why, yes I do. So here's what I've got. The square root of 8 is the same thing as 2 times 2 times 2 times 1. 2 times 2 times 2 times 1. Now, remember those perfect squares? I want to look under here and I want to circle anytime I have 2 numbers that are the same. So I'm going to circle these right here. When I have 2, I smush them together and I bring 1 out. So here's what this happens here. This becomes 2 times 2. I'm going to bring 1 out to the front, and now these are gone, and I just have 2 times 1. What's 2 times 1? It's the square root of 2. So the square root of 8 is the same thing as 2 square roots of 2. Those of you that are going to go further in math than just basic algebra or college algebra, you'll get really good at these and you'll be able to do these super quick in your head. Right now we just did your very first one and you're probably like, what? Don't worry, we'll get there. Alright, so let's try another one. Let's try the square root of 45. Okay, so I know I could put it in my calculator and get some decimal, but I don't want to do that. So skip down a little bit, come down here, and we are going to do a birthday cake. When you see 45, which prime number jumps out at you like, oh, I'm going to divide by that one? Of course, 5. Why not? So we're going to divide by 5. 5 goes into 45 9 times. Another layer on the birthday cake. I can't divide by 5 anymore, but I could do 3. 3 goes into 9 3 times. I'm going to put another layer on my birthday cake. I'm going to divide by 3 again. Boom. I've got my candle. So the square root of 45 is the same thing as 5 times 3 times 3 times 1. Remember, you're circling the doubles. Circle them up. So I've got 2 3s. They are going to come out to the front. So I'm going to have this 3. I'm going to mark it off out in the front. Square root of 5 times 1 is left. So that's 5. Here's my answer. The square root of 45 is 3 square roots of 5. Okay, so you should have a paper, and if you haven't gotten it yet, you want to get it. Why didn't Croc, I don't know, like to go sailing with baseball uniform designers? Oh my gosh, I should go to bed. All right, so here's what I'm going to do, and this is what I recommend for you to do too. I recommend you get a sheet of notebook paper because we are going to work these on here. Now, I already did the first 2. Aren't you excited for me? We said the square root of 8, if you still have your paper, the square root of 8 was 2 square roots of 2. So the square root of 8. Simplify each expression below and find your answer in the corresponding answer column. Write the letter of the exercise in the box that contains the number of the answer. Okay, so 2 square roots of 2. So L, number, no, that's not right. 12. 12 was 2 square roots of 2. So I'm going to go to 12. And I'm going to write L. There we go. So I'm going to mark off, I think we should mark them off. 2 square roots of 2. And then we did the square root of 45 was 3 square roots of 5. So 45 was 3 square roots of 5. So 25 is going to be I. So 20, I think that's an I. Is I. And I'm going to mark those off. Sorry, my computer's lagging a little bit. I've got a video that's processing that I just made. All right, let's do the square root of 50. So I'm going to come down here. I'm going to do the square root of 50. All right, so I'm going to make my birthday cake. I'm going to look at those prime numbers. 50, 5 jumps out at me again, so I'm going to start with the 5. 5 goes into 50 10 times. I'm going to keep using 5 because 5 will go into that again. 5 goes into 10 2 times. Another layer on my birthday cake. Can't use 5, but I can use 2. 2 goes into 2 1 time. Alright, so the square root of 50 is 5 times 5 times 2 times 1. Circle it up. Circle the 5 and they come out to the front. So that means I have a 5. Those are gone. 2 times 1 is 2. So 50 is 5 square roots of 2. So 50 is number 4. So 4 is A. Alright, so let's do 12. Alright, so the square root of 12. What prime number? Now you may be thinking, oh, we could divide by 4. We could. But is 4 one of those prime numbers? No. So we should probably start with either 2 or 3. I'm going to start with 2. Just 2 is kind of the one that jumps out at me. 2 goes into 12 6 times. I'm going to divide by 2 again. 2 goes into 6, 3. Can't use 2 again, but I can use 3. It's a prime. 3 goes into 3. 1. There's my birthday candle. All right, so 2 times 2 times 3 times 1. Circle up the ones that match and bring it out to the front. So 2 square roots, those are gone. 3 times 1 is 3. So 2 square roots of 3. So 12 is 2 square roots of 3, so 20 is t. All right, so hopefully you kind of have the idea. There's some big ones over here. We may want to find a bigger prime number to use than the ones we've been using. We could always use 2, but just remember you're going to have to keep track. All right, so 98. I'm going to do this one. This one's going to be big. Let's start with 2. I'm going to divide this one. I can't do 2, but 49, I'm thinking I could use that 7 right there. So that is 2 times 7 times 7 times 1. Circle up my doubles. So that's 7 square roots. 2 times 1 is 2. So the square root of 98 is 7 square roots of 2. 7 square roots of 2 is 18. 18 is going to be O. All right, so you're going to keep going on this. Work with your partner if you need to. Remember, you can put this into your calculator. Put the square root button. Let me see if my calculator's on enough that I can actually show y'all where to put that. So, well, yes, I know it's pretty low. Second and then x squared gives you that radical. When I put in 1, 1, 2, 3, 1, 2, 3, and hit enter, oh, look at that. So if it comes out to be a nice, neat number, then you can just go ahead and use it. But if it doesn't, then you're going to have to do that birthday cake method. Most of these you're going to have to do birthday cake. All right, so good luck on that.